Hello and welcome to this video. In this video, we will learn about methods associated with string, and in the next video, we will learn methods associated with string slices. All right. So without further ado, let's get started. So we have a string s we create from string from, and we use the function as bytes. As bytes will create a mouse over it. As byte will take a string and convert into a reference or slice, a reference of an U8 array. Okay. So as you can see, the example is taken from documentation. We have the same values. Hello is there. So this entire program is from the Rust documentation, the standard library documentation. I have just filtered the useful functions. I'm not covering all of them. The most useful ones I will cover. So the hello will be 104, the byte value, e will be 101. So you can count that these are sequential in nature. E, F, G, H. So if E is 104, H will be 104, L will be 108, and O will be 111. Okay. If I run this, oops, if I run this, the assertion will succeed. We don't have problem. Now we create another string foobar. Okay. From foobar, we convert it to a mutable slice. So the function for that is as mute str, as underscore mute underscore str. Then we take this mutable string and we invoke make ASCII uppercase. So it will convert the small case foobar to capital case foobar, which is our assertion. So we run this again, it succeeds, no problems. Now we convert this. So we have this as str. So it will convert a string to string slice. So as you can see, it converts it into not slice, it converts it to &str. And it is incorrect saying it is a slice. It is &str. Okay. Slices are part of some string. Okay. So this is a reference of a string object. So we run our assertion. There will be problem with this. Oops. Now we have with capacity. So suppose we have a string. So in my previous video, I have said that a string has three properties. One is the pointer, second is the city, third is the length. Suppose I know that I will be making a string out of small strings by using push underscore str. In that case, I can beforehand allocate a string with large capacity. Okay. So when I initialize this string with capacity, there will be no content, but allocation will be done. Now note that even though we have requested 10, it may allocate more than 10. Okay. That depends on the allocator of Rust. All right. So next is clear function. If you use clear function, then the string will be entirely removed. The contents will be removed, and you can invoke is empty. Clear is empty. You can invoke after clearing the string, and it will be empty. The length will be 0, but capacity will remain 3. That is, the memory allocated is not deallocated or freed in programming terms. Now we look at the drain function. So suppose we have a string alpha is alpha and beta is comma space beta is beta. So what we do is we find beta, okay, and we take its offset. Okay, the find function will return us the offset. You see this, it returns you option usize. So option means it could be either none or it will have some value. So we use unwrap OR. Okay, the default value of this is slen. Okay, the length of s. That if beta is not found, it will point to the last character. That will be our offset, and from our offset we take a slice. Okay, so here's the character will be at beta, so everything before that will be taken into the string t. So we take drain, we pass the offset, and we collect that. Okay, so what drain returns is drain returns a drain object. Okay, and it takes range, and then you can collect it. So if you see collect, it trades on a collection. So drain is a collection in this case. So once we have that t, don't worry if you don't understand all the terms. If you have t, then you can compare it in the assertion that alpha is alpha comma space, and beta is beta will remain in c. In s will still have beta is beta. Run this. Now remember that one more thing. Okay, dot is full range. Okay, full range will clear entire string. So we test this assertion also. Okay, so we are now done with the drain function. Now we see the insert function. Insert function will take the index and it will put at that index. At that index, the character will be put. Care has to be taken in this case because the index should be. No, I don't remember. I will have to look at documentation. Yep. Index should not be larger than string length, and it should lie on a char boundary. So for ASCII it is simple, but for Unicode you will have to know how many bytes it will take. So we run this. I have already run this program, so there will be no problem. So we will stop running cargo run, and we will see this without cargo run. Suppose suppose we have another string bar, and we insert string at index 0 foo, then it will become foo bar. Let's run cargo run in any case, just to show. So the insert str function inserts a string at certain index. If we insert at index 1, it will become bfoo ar, bfoo ar. So you see, right hand side is bfoo ar here. So assertion fails in this case. If we make this bfoo bar, bfoo ar, it will succeed. Next method is into bytes. So you can have a string and you can convert it into vector of U8 by calling it into bytes, and then you can take the slice, full range slice is used here, and then you can compare it with bytes. So the function is into bytes to convert it into a vector of U8. So obviously the cargo run succeeds. Now we already know the length of the string is determined by the function len. So we'll skip that. We skip this also. This is interesting. So let's do this. Now note that this F which you see is not ASCII character. Okay, it is a Unicode character. So if you count its length will be 4. Okay, because those will be number of bytes. But if you do a chars count, it will be 3 because F, even though it take 2 bytes, will be counted as a single char. So you have to be careful about character count and length of the string. Now we look at the pop function. Pop function extract last character from the string. So the first pop will remove the C. It's not really a C, with a crescent moon on top of C. I don't know what it is called. Second pop will extract B, and the third pop will extract A. And once all are extracted, extracting further will give you none. The pop, as you can see, will give you an option of char or U8. It gives you option of char. You need to see here. This is the optional char. We have not covered yet option and result enums. Maybe I should cover option and result enums in the next video. That would be interesting, so that we can understand that what option is. Okay. Similarly, you can push like pop. So the push will push at the end. So if we have a string ABC and we push 1, 2, 3, it will become 1, 2, 3. ABC 1, 2, 3. So assertion succeed. I have not told that what is an assertion. I think I have forgotten to tell about assertion. Assertion basically tests for a condition. Okay. So this is called assert for equality. This is assertion for equality. So if it will take 2 arguments. If both the arguments are equal, then assertion will be successful. That's what assertion is. I might have told it in my previous videos, but I don't remember it. So next one is push str. So we have foo, we have bar, we push bar, so it becomes foo bar. Now we have a remove function which takes an index and removes a character from that index. So once you remove AC, B will be the only character which will be available at index B. You can replace a range here, which we have seen. So what we are doing is we find B, we take beta, we find beta and take beta offset, and then we replace the entire range with A is capital alpha. So the change is initial string was alpha is alpha. Now we replace that with A is capital alpha. So this is the new string, and then we take the offset again of beta. I think it has come twice. I pasted it twice. Bad copy paste. So this is the place range. Then we have reserve exact. It's more like with capacity, but in this case, what happens is, suppose you have a string, okay, and you want to reserve 10 more bytes, then you can call reserve exact. It will reserve 10 more bytes. So in this case, our string is empty, so the initial capacity is 0. So in this case, capacity will become 10. 0, we add 10 more. Suppose we have a thing here and we want to get rid of a certain character or character set, then we can invoke the retain function. Retain function takes a closure. We have not yet studied closure, but this f is of this type, fn mut. We'll see what this does is. Okay. Now you ignore this. You can actually skip this. Essentially what it does is it takes a char from the string. If the char is not equal to underscore, then it returns true. Okay. And then finally what will happen is f will be returned, o will be returned, ob will be returned, ar will be returned, but underscores will be not returned. I mean true will not be returned. Okay. So if you see here carefully, this function returns a bool. Okay. So example is given here. If you see, remove all characters is such that fc returns false. Right. So it not necessarily it has to be a closure of this form. Okay. It can be a big function, and you can apply arbitrary logic in this case. Okay. Now we look at reserve. So reserve is like reserve exact, but it will reserve additional. It is not exact in nature. In this case, initial capacity may be 3 or greater than 3. So the final capacity will be definitely greater than 100. Similarly, we have shrink to. So if we shrink it to, if we shrink it to 10, the capacity will become greater than 10. If you shrink it to 0, it will not necessarily shrink to 0. Okay, but the capacity will be greater or equal than 3. So the minimum capacity shrink to will not be honored always. If the string requires certain capacity, the compiler will hold that capacity. Now we have a split off. This splits a string at a certain index. In this case, we want to split at 7th word. So hello comma space will be in the first part and world will be in the second part. So we have this. So this assertion also succeeds. Control key is misbehaving. Now we have truncate. Truncates to those many number of characters. New length. It takes argument new length and will truncate the string to that many characters. Now suppose, just for fun, let's give it 10. Let's see what happens. Assertion will fail. Okay, but you see, it did not give us. It is dangerous to increase this space boundary just like that, because it might overlap with something else. So if you see truncate, shortens this string to specified length. If new len is greater than the string's current length, this has no effect. So giving a larger number will not have any effect. That's why Rust is very safe language. It just doesn't allow you to do nonsense, because truncating to 10 is nonsense. All right. So now we have this. We have created a string with capacity 10. So the length is initially 0, but capacity will be more. So when we push 10 characters, this will not reallocate the string. All right. So the capacity will be equal to cap here. Okay. But once it has finished the capacity and you push further, it will reallocate the entire string. All right. So with this, we come to the end of our third video on character and string types. In the next video, we will talk about &str methods. Okay. Note that those methods will also be applicable to string types, because string gets all functions of &str types. Okay. And after that, we will proceed further into control flow. So I hope you have enjoyed this video and found it useful for your Rust programming purposes. We have not still gone into depth of the language, and there will be some interesting programs I will create for you guys. So please subscribe, like, comment, share to your heart's content, and these actions motivates me to make more such videos. And obviously, if you like and subscribe, then the reach of the channel increases, and with subscription you get notifications when I upload new videos. Make sure you if you are on mobile, then make sure you allow YouTube to send you notifications, and on desktop or laptop you have a bell icon and it will send notifications to your mailbox if you select the bell icon. And the second purpose is that it motivates me. It highly motivates me when some activity happens on YouTube. Thanks a lot for watching. Happy programming.